Okay, so this is the third take. Okay, I'm going to talk to you, I'm Laura, and I'm going to talk to you about first derivative tests and second derivative tests. These two things can help you a lot, especially when it comes to graphing, but also on the test. So first derivative test, the most important thing it does is tells you where f of x is increasing or decreasing. And finding a point where that changes is finding the maximum and minimums, and that's pretty easy. We know how to do that. And then second derivative test, the number one thing it does is determine the concavity of f of x and where it changes, and that's inflection points. It can also tell you where maximum and minimums are, but it's kind of iffy, and there's certain points where it doesn't work. But if it doesn't work, no problem. We have the first derivative test, and that never fails. Okay, so I have two problems, and I'm going to start with the first derivative test, find where it's increasing, decreasing, and then find the maximum and minimums. Okay, so first we're going to take the first derivative, 2x plus 3, and then set this equal to 0 to find the critical points. So 2x equals negative 3, x equals negative 3 halves. Okay, so now we're going to put this on a number line. The reason we're doing this is because we're trying to find what f of x is doing on the left and the right. If f prime of x is negative on the left of this, it means it's decreasing, and if it's positive, it means it's increasing. So we're going to find it out. So we're just going to pick random test points. So for me, I'm going to pick negative 2 and 0 because those are easy. Okay, so plugging in negative 2, you have 2 times negative 2 plus 3, which is negative 4 plus 3, which gives you negative 1. So that's a negative number. So we have a negative value over here. And so 0 plugging in 0 just gives you positive 3, so you have positive over here. What this means is that f of x is decreasing here and increasing here. So we found that from negative infinity all the way to negative 3 halves, f of x is decreasing. And from negative 3 halves all the way to infinity, x is increasing. So this looks kind of like a parabola, what I've shown you. And where it changes, right here, we have a minimum. So at this point, negative 3 halves, and then f of negative 3 halves, plugging it back in. I'm not going to do that, but plugging it back in, that gives you the point where you have a minimum value. Okay, right, I've done those things, and now I'm going to show you the second derivative test. Okay, so we're basically going to do the same thing, take the first derivative, but we're going to go farther and take the second derivative. So f of x is 4x cubed, f prime of x is 4x cubed minus 12x squared. And then go ahead, take the second. Shoot. 12x squared minus 24x. Okay, so that's f prime, the second derivative of f of x. So we're going to do the same thing. We're going to have a number line. Oh, no, just kidding. We have to find the zeros first. Set this equal to 0. So I'm going to factor first. Okay, so you have 12x equals 0 and x minus 2 equals 0. So you have x equals 0 and x equals 2. Okay, so now we're going to have our number line. Plot these values. And then, again, pick test points. But instead, these are going to tell you if f of x is negative, then it's not decreasing. It means that it has, it's concave down. Yeah, so if we plug this back in and it's negative, then we have concave down. And if it's positive, we have concave up. Okay, so let's do that. We're going to plug in negative 1. So negative, 12 times, I don't feel like writing it. Okay, so that's going to be positive. And then negative 24 times negative is going to be a positive plus a positive, and it's going to give us a positive number. 1, that's going to be 12 minus 24. So that's going to give us a negative number. And then 3, plug that in. That's going to give us negative, it's going to give us 36. So that's going to be positive. Okay, so what this is telling us is that at this point, at negative 1, but all the points, at negative infinity all the way to 0, x is concave up, because this value is positive when we plug it back into f prime of x. So from 0 to 2, f of x is concave down. And then here, from 2 to infinity, x is concave up again. Okay, so what this kind of looks like, it's concave up, and then all of a sudden concave down, and then concave up. So at these points, awkward, but at these points, the concavity is changing. Here it's changing from concave up to concave down. So at x equals 0, there's an inflection point. And here it's changing from concave down to concave up. So at 2, there's an inflection point. So yeah, whenever it changes, there's an inflection point. And technically you're supposed to write this like 0 and then find f of 0, plug it back in, and then 2 f of 2, and that gives you your points where you have inflection points. Okay, I'm going to erase this and then show you how to find your maximums and minimums. Okay, so the first thing you do whenever you find your maximum and minimum is get your critical points. Because the critical points on the graph of f of x are always the maximums and minimums. So, right, so because there's maximums and minimums, yeah, on f of x, there's a max and min where the slope is 0. So that means f prime of x, because f prime of x is a slope, that's where this is 0. And so that's why we take, that's why we take the first derivative. Okay, set this equal to 0, you get x equals 0 and x equals 3. Okay, so instead of finding a number line for this, we're just going to take our critical points and plug them back into f prime of x, so the second derivative of x. What this is doing is telling us if the graph is concave up or concave down at that point. So if the graph is concave up at that point, then we have a maximum. And if it's concave down, then we have a minimum. Okay, so that means, so this would be, if it's concave down, that means the number we got was negative, and if it's concave up, the number we got was positive. Okay, so here, the number we get is 0. What this means is that this test fails for x equals 0. And that's not a worry. We can go back and plug it into the first derivative and get our zeros, or max and mins that way, but the second derivative isn't going to help you on that one. But we still have this one to test, so let's do that. So we have 12 times 3 squared minus 24 times 3, 36. And so that's a positive number. And because it's positive, that means the graph is concave up. It makes a smiley face. And that means we have a minimum at wherever 36 is. So 36, comma, f of 36 is our minimum point for this graph. And remember, there's another one. Don't forget to go back and test this into f prime of x. And I think that's it.